Okay, good morning and welcome to the next episode of Releaseworks Curiosity to Growth. We've designed this series of events specifically for software leaders. We've designed the event to enable you to take your software product to the next level, right? To help you increase maturity in your technology operations and obviously avoid common pitfalls and risks while you are doing so. Now, today's episode is about architecting for scale and how do you survive the traffic peaks in your SaaS application when you are lucky enough to actually have lots of users. With me today, we have Joe Poser, who is our lead cloud engineer at Releaseworks. Hey, Joe.
Hello, nice to be here.
Good stuff. Good stuff. Maybe let's start with give us a 30-second introduction into yourself and what you're doing at Releaseworks.
I'm Joe. I'm a lead cloud engineer at Releaseworks. I've been working in kind of infrastructure, probably pushing about 10 years now. I've been in kind of cloud and DevOps for probably 7 or 8. Prior to that, I was kind of a Linux sysadmin. So I've come into the field from that kind of background. And over the last few years, I've worked at companies of kind of all very early stage startups with 3, 4, 5 employees. That probably includes us actually as a company, all the way up to multinational companies with huge infrastructure functions. So yeah, I've seen a lot of things.
Very good, excellent. Good stuff. So let's jump into the topic. If you do have any questions, please do send your questions. There's a form at workshop.release.works/ask, and we'll pick them up after the content. So, talking about traffic peaks and surviving traffic peaks, I think the first thing to understand here is, when do you actually start to think about scalability in your application? What do you think, Joe? What's the right point for in the life cycle of a software startup?
So I think you should be thinking about it kind of as early as you can, but you shouldn't necessarily be acting on it until it's clear that it's worthwhile. If it's the one thing you want to do, especially if you're an early stage startup, is you want to get to market as quickly as possible, and you want to understand whether you've got good product market fit, and the thing that you're going to build is going to be successful. So if you worry too much about how am I going to handle 1 million plus daily users when at the moment you've got 0, it's probably not the right time. But at the point where you can see there's okay, right, this is getting a bit of traction, we're getting regular increases in daily or hourly traffic, or okay, we're starting to see where our what our traffic picture is. Is it coming in at sort of 9 a.m. in the morning? That kind of thing. That's probably the point where you want to start going, okay, how do I take this and turn it into something that can grow?
Yeah, absolutely. I think we've seen too many examples of teams implementing huge container orchestration platforms like Kubernetes on day one for their MVP, right? Where scalability is not an issue in any shape or form, right? So yeah, definitely agree on that. There's no point solving problems that you don't have. Right. Obviously, keep in mind that you're building something that will have to scale at some point, right? But there's no point building the scalability in from your MVP stage. Good stuff. Good stuff. So let's talk about talking about MVP. Let's talk about the kind of the usual infrastructure approach for companies that are building MVPs, especially if they are not necessarily cloud native as such, right? Typically we would see a single virtual or physical server running an MVP with everything in the single server itself, right? Or what do you think, Joe? Is this something that you've seen as well?
Yeah, absolutely. Yeah, and I don't think it's a bad thing, right? Like, if you go with what this is I got my start in the industry working on virtual machines. Things like running little WordPress sites in running multiple WordPress sites on a single very cheap VPS from I can't remember exactly the provider, but it was one of the not one of the big names. And that can take you quite far, but at the point that there will probably come a point, especially if you're running your entire business out of one server, where it becomes an issue, right? It's it's a single point of failure. Managing virtual servers, managing server operating systems is operational overhead. You have to deal with things like patching schedules, and there are things you can do to alleviate some of those things. But I think kind of some of the initial things that can happen. Say you're running that traditional LAMP stack. I'm not sure how many people are doing that these days, but maybe they are, and they've got that MySQL database running inside that server. One of the first things you could do is you could split that out into into its own server, so that if you don't have to scale everything at the same time. So if you've got a huge amount of pressure on your database traffic, you can give that a nice beefy server, but maybe the web server itself is not getting very much traffic, and you can keep that nice and small. So you start to compartmentalize things and identify where your bottlenecks are, and once you identify one bottleneck, that's probably where you start to expose all the other bottlenecks, and that's where more complicated solutions might need to start.
Absolutely. Yeah. I think what you mentioned there around the kind of the single server, or a two server approach, definitely around redundancy, right? If that server and when that server fails, right, regardless of whether it's a virtual or a physical server, all of the servers are physical at the end, right? And they will fail because hardware just fails, right? And when that hits you, then your service is down and you can't do anything about it, right? That's absolutely fine for an MVP, right? But when you actually have paying customers, suddenly it's not all right. They expect you to actually run something that is available when they need it. Right? Good stuff. And yeah, obviously we're talking about scaling today, and scaling virtual or God forbid physical servers is hard, right? You in the worst case, you will actually end up buying thin and setting it up in a data center, right? So that is not an easy scalable approach. Now, obviously, that's the right approach for organizations that are at scale already, right? But typically not for a startup.
Yeah, no, I totally agree.
Good stuff. So let's jump from 0 to 1, if you will. Let's jump to what good looks like in terms of a scalable, cloud-based, modern application architecture. Right. Now, this is something we call a scalable application stack, right? It's an example of one. It doesn't include all the bits and pieces, all the details of real world application stacks, but it does have the moving parts where they're supposed to be, right? So let's talk about the left hand side first, the front end stack more specifically, and we've drawn a couple of things in here to consider starting from the serverless object hosting side of things. So would you mind, Joe, just explaining a bit about the serverless static object hosting side of things? Why would this usually be a good idea for hosting front ends?
I think there's a couple of things. One is it's just really easy. Like it's one of those things where when you find out about it, you're like, why haven't I been deploying? I mean, it didn't exist, 20, 25 years ago. But at the point where you can, I remember writing websites as probably as a teenager, writing websites in HTML on like Notepad. You're like, how do I get this on the internet? And then you start learning things about like web servers. And at the time, I guess it was you get an FTP server and you upload the file onto it, and that kind of made sense. But you're like, why do I have to why do I have to deal with this kind of stuff? And like you can just upload your files to S3, stick a content delivery network. If you're talking about S3, then it's Amazon's CloudFront, and it just works. It doesn't lose it doesn't lose data. Availability is ludicrous in comparison to like basically everything else. And for like 90% of people, like S3 is designed to scale to ludicrous degrees. Like there are businesses that are doing absolutely monstrous things with S3. So a few website reads, even if you get to quite a large scale, it's very affordable, and it's affordable from day one as well. So it's a service built for giants. So if you're less than a giant, then it can be it's very cheap.
Yeah, indeed, and fundamentally, what we're talking about is very much around cloud native and serverless, right? If you can avoid maintaining HTTP servers, maintaining web servers, then you should do something else, right? If you can avoid worrying about virtual servers for your front end, especially, that's a good way of doing it, right? So yeah, in terms of the cloud platforms, obviously pretty much every major cloud platform has a static object storage service. Typically, we tend to work with AWS S3, as you mentioned, right? Azure has their equivalent called blob storage as well. More often than not, these services tend to require a content delivery network, a CDN, in front of them, which also improves performance across geographies as well by caching the actual files closer to your users and things like this. One thing to note on the front end side as well is around dedicated front end hosting platforms like Vercel, right? There are a number of platforms that provide not just the static hosting, but for example, testing environment management for your front end, and very opinionated deployment frameworks for continuous delivery and things like this. Joe, you can think of on the front end platform side. I think we've been working with Vercel. Heroku does something quite similar as well, right?
Yeah, no, I've actually been working on a number of these platform as a service providers recently, and they all do seem to be kind of offering very similar features, and the features are really good and they're really easy to get up and running with. Vercel's obviously a big one if you're in the Next.js space. Netlify is another one. Those two seem to be on the more expensive side. Cloudflare Pages, for some reason, seems to be just like ludicrously cheap. And if you're, already, looking at Cloudflare, for your CDN, then it's, you know, it seems like a really good product actually. And Azure and AWS have Amplify. We've got an engineer who we've just taken on board. He's got a bit more of a web development background, and I know he's built stuff with Amplify in the past, and he was just, you know, it gets you from a position where you're like, you know, how do we deliver this website? And, you know, you can just start writing a website, and all of the kind of best practices around, you know, things like preview environments and things that everybody wants, especially things like marketing teams, just comes out of the box. I think that there are actually some really impressive products there. I can see why they're taking off.
Yeah, absolutely. Yeah, no, definitely. I think there are a couple of caveats to what we're proposing here, right? First of all, you know, this actually requires a decoupled front end, right? You know, you should have a front end component that is effectively a React application or an Next.js application or an application that can run on the web browser, right? And you know, it doesn't really work with a LAMP application stack, for example. No. So one of the prerequisites definitely is to decouple your front end from your back end, right?
This is Jamstack approach, isn't it? Which I think Netlify actually came up with the terminology for. So, but it's definitely, I mean, it's proliferated everywhere, right? And there's a good reason for it. Is it disaggregates your complicated transactions from your browser, and it means you can have, you know, a really fast loading, you know, first paint, which is very important for your Google search index rankings, which is a thing, you know, that everybody should care about very deeply. Yeah, absolutely. I think the other kind of thing to keep in mind around these very opinionated platforms are the limitations, right? You know, they are really good for doing you know, what you generally need to do in this space, but usually at some point when your product matures, when you mature as an organization, you know, there starts to be an increasing list of use cases that they just don't support, right? And at that point you start running into the limitations of these platforms, and usually, in my experience, organizations tend to start looking at replatforming their product at some point in the life cycle, once they've kind of you know, taken advantage of the fact that they could get to market very quickly with a platform as a service. But you know, a few years down the line, I think some people say 7 as an average. You know, organizations tend to run into the limitations and just need replatforming, right? But that's a natural part of the life cycle. There's nothing to be afraid of, right? Good stuff. I think something to point out in this diagram as a whole is the space intentionally left blank on the left-hand side around the database and the infrastructure side, just to kind of emphasize the fact that when you decouple your front end from your back end, you know, your front end should be an application that you can host using a static web server, right? So it doesn't have any kind of server-side requirements other than actually being able to serve you know, your HTML and CSS and JavaScript files at the end of the day, right? Good stuff. So looking at the right-hand side, then very much around the back end and the API side of things. We typically start to break things down into a few components, right? So if you consider the previous slide where we had a single server or a couple of servers to run your application, you know, we would typically start introducing technologies like Docker containers to provide a level of horizontal scalability into your application, right? And obviously, when you go from a single application instance to multiple application instances, there's a natural requirement for a load balancer to be able to redirect traffic between these multiple application instances, right? In terms of the load balancing side of things, I think there are 2 main approaches. Now, keeping in mind that typically when we decouple a front end from a back end,
on the backend side, we start talking about APIs, right? And we start coming up with an API strategy for how do we actually make the backend manageable and make the interface between our front end application and the backend services something that evolves in a controlled fashion, right? And typically technology startups, don't just have a single front end. They might have mobile applications. They might have different front ends for different target user groups and demographics within their business, and so on, right? So on the load balancing and the API side, do you have any points around technologies, Joe, that you've seen out on the field?
I mean, I think it tends to be very tied directly to your cloud providers. Like, you can roll your own, right? Like, there's, I spent a lot of my early career configuring Nginx load balancers, or even just Nginx reverse proxies, right? And Nginx is a great load balancer, but you run into, it's not a problem, but it's an operational overhead, right? You need to have an engineer who understands how to write Nginx config. You need to patch Nginx. You need to run the servers it runs on. You need to consider things like failover. Whereas, Amazon's basically done all that for you at this point. And you can just deploy, one of their types of load balancer, depending on what your, the type of service you're running your backend on. And they've done things like handle automatic failover. Availability is incredibly high. And they integrate really tightly with a lot of their, sort of downstream services. So you mentioned kind of API gateway, right? API gateway and those sort of things integrate really nicely with kind of, we haven't really spoken about it here, but serverless, which is a phenomenal way to scale really, really, really linearly. As basically every single API call is, spawns a new serverless function. There's very little contention, and we've seen organizations take that approach and be really successful with it. It comes with some additional complexity around managing all of those serverless functions, so it may not make sense if you're not willing to swallow that complexity. In those regards, some service like Fargate, I'm probably skipping ahead here, but an application load balancer integrates so nicely with Fargate. It's a really compelling stack from an operational overhead perspective.
True. Yeah, absolutely. Yeah, I think one thing worth mentioning around serverless is that there are multiple levels, right? When we're talking about serverless, or as some people like to put it, somebody else's servers, right? There are multiple levels of abstractions. We have things like AWS Lambda, which is the AWS functions as a service, serverless offering. Then, as you mentioned, AWS Fargate, which is more of a serverless computing platform, so running containers without having to worry about where the containers run, right? And that is definitely a very compelling approach if you don't have sysadmins and if you don't have people who are really passionate about patching virtual servers, right? So yeah, absolutely. On the on kind of the container orchestration side of things, typically when we take a monolithic application, right, and we start chipping it into something that runs in a container quite nicely, we will end up needing to run those containers on an orchestration platform, right? So and container orchestrator has a few kind of basic tasks that it needs to accomplish, like running a set of containers, a defined set of containers with a certain level of CPU, certain level of memory available to them at all times. Container orchestrators tend to ensure that the containers have certain disks attached to them if needed, and things like this, right? Now, obviously, as with pretty much everything on a modern application stack, various cloud providers provide their own container orchestrators as well. In terms of a use case where your application hasn't been containerized before, but you're looking to containerize it and run it on, for example, AWS. What do you think, Joe? What's the best approach for the container orchestrator? Then what would you go for in a scenario like that?
I mean, depending on your kind of level of maturity. I mean, I'm a big fan of Fargate and ECS as a service. I think the way it integrates with, we'll talk about things like infrastructure as code in the future, but it means that there isn't the requirement for an additional layer between the container orchestrator and like the other services that you're integrating with. So with some, with a tool like Kubernetes, which is obviously very popular within the industry and is very powerful, in order to get it to talk to other things, you often have to, run things like, like custom operators and things like that to get it to do things like, expose. So in the case of like Amazon's EKS, you need a custom operator to get it to, be able to expose your, if you're running some kind of like web-based service and you need to expose to the internet or even to, other services outside of your cluster, you need that integration, and you don't have to do that with ECS. The same goes for app services as well, actually. It means, your configuration stays within the cloud provider and doesn't start proliferating out into your container orchestrator.
Yeah, that makes sense. Very good. Before we kind of talk about the infrastructure, the pure infrastructure side more, let's talk about databases, our favorite pet peeve, building applications, right? So something that I've found quite interesting is the introduction of serverless database platforms, especially when it comes to kind of more open source kind of generic database engines like MySQL, Postgres, and that side of things. What do you think are the best benefits when it comes to the serverless database engines?
I mean, Amazon Aurora serverless basically seems like a dream to me. Like, I've spent, it's one of the biggest. I mean, RDS. I've said this to you before. I think RDS was actually Amazon's killer app for a long time, because managing databases is really hard, right? It's database admins aren't as common as they used to be, and I think the reality,
especially in startups, right?
Yeah. But even in larger organizations, you come across and you're like, is there a DBA I can talk to? The answer is no. It's it's the infrastructure team. And it's because tools like RDS have made it easy, right? You don't have to, things like backup and all of the patching and the really complicated, difficult stuff, and there's a support contract on the end of it. If democratized databases, right? But the big problem with RDS is that, although it was very easy to scale, your web servers and your stateless parts of your application, the moment you needed some state, and then there was DynamoDB, and that's existed for a while. But if you needed that kind of relational, you were kind of a bit stuck, right? You couldn't. You had to, find a quiet period in the night to, upgrade your servers, and there'd be minimal downtime, especially if you're running on, sort of multi-AZ things where there's multiple servers underneath it running. But there's still, it's still downtime. It's still, has to be planned in. It probably has to be done in the middle of the night. Probably needs an engineer there. If you told me I could have a database that scaled in the same way that, I could make a Fargate service scale, and the answer is you can now, right? So
exactly.
It's a really exciting technology, I think.
Exactly. Yeah. Indeed. Yeah. I think one caveat to that is definitely around cost, right? Just like with RDS being as you say, the killer app for Amazon, I think it tends to be the most expensive part of your AWS bill as well, right? So they definitely provide a lot of value at a cost, right? But yeah, as you say, typically this still makes a lot of sense for the vast majority of organizations, especially smaller organizations, because you get to outsource a lot of the stuff that a DBA would have to do to your cloud provider, right? And that tends to be a very good approach. Now, very similarly on the kind of the pure infrastructure side, the servers, application servers, and stuff like that. There are offerings, for example, in Amazon AWS Fargate, which take away the complexity of having to maintain servers. But again, it comes at a premium, right? You'll pay more for the pure performance by signing up to a platform where you don't need to worry about all the bits and pieces, right? Yeah. Now, in terms of the couple of options, if you will, in the infrastructure layer of this diagram, obviously on the left hand side we've got the serverless container platform side of things, right? So if you are running pure containers on your back end, and if you don't employ system administrators in your stuff, then it probably makes sense to go with a container platform that is serverless, i.e., you outsource the trouble of maintaining security patching and available memory and available disk space and all of that jazz to the cloud provider themselves. Right? Now, at some point in a startup's life cycle, it might actually make sense to run virtual machines, right? Just like I previously alluded to the large companies at scale. Actually, it might make sense to run physical servers, right? And that's perfectly fine, right? But typically, this requires a level of scale that is not feasible for a startup. So what we tend to concentrate in, and pretty much every client engagement that we do with startups is very much around serverless technologies, right?
I think there's also an argument, and it's definitely coming up more and more in the industry. Actually, if you really understand your traffic requirements, like say you've got a really stable load, there is an argument to say that maybe you just go, okay, right, we know we're going to run this, because a lot of this is an argument between capital and operational expenditure, right? Like sometimes it's better to have operational expenditure if your usage is quite spiky, because you don't have to provision for say you've got 3 days a year when you do 10 times, 100 times, 1,000 times the traffic that you do for the rest of the year. Then you have to buy a rack of servers that can handle that, and for 360 days of the year they're 90% idle. But if you've got a really consistent load, there is an argument to say maybe you want to just buy a few switches, a couple of compute instances, and maybe a couple of database servers, and just stick it in a co-location and run it, right?
Yeah, absolutely. I think on a similar note, I've seen a lot of organizations that build data centers in the cloud, right? Yeah. They set up a bunch of virtual machines that reflect the maximum load that they will see on Black Friday, right? And hey ho, they are 99% idle, 364 days of the year, right? And that's basically handing money to the cloud provider for things that you have zero requirement for, right? So even getting to the cloud that's not a silver bullet, right? You still need to be able to actually take advantage of the cloud and the flexibility that it provides.
Yeah, absolutely, yeah.
Good stuff. Excellent. So let's talk about a few of the things that you need to get from A to B, right? The single server, non-scalable, non-highly available solution into something that reflects best practices and kind of the right way of building scalable applications. Obviously, the first thing is around the cloud platform, right? For you to be able to realize the benefits of having a flexible, scalable architecture without paying for the Black Friday price every day of the year. You do need to run your application on a modern cloud platform. There are the big three, I think, are still very much leading the market, being Amazon AWS, Azure, and Google Cloud. Have you seen any other major players in the field recently, Joe?
I know Oracle made a big push recently. We all have our opinions on Oracle, but they were very competitive price wise a couple of years ago, and made quite a lot of noises. Those noises seem to have gone away a bit. So I suspect that then maybe they're struggling. I mean, there's some really big names that have been trying to get into the cloud space, like IBM. But then there's the really smaller shops, like DigitalOcean is really popular with hobbyists, and can be if you've got the skills in it, can be it's very compelling from a price perspective. Might not necessarily have the scale of AWS or the reliability, but it's definitely there. Oh God, there's that other one that advertises all over the place. That's named escapes me, so I'll stop talking.
So yeah, probably they need to advertise a bit more then.
Well, no, they advertise loads. It's just I haven't listened to the podcast that they advertise.
Fair enough. Yeah, good stuff. The other thing that we kind of touched on already is around decoupling the front end and the back end. Now, I think theoretically you could run a monolithic application that provides the front end capabilities in the same unit as the back end capabilities. But typically, at least in my experience, if you go through the effort of decoupling them into two separate components, especially if you're planning on building a mobile application, if you're planning on building different facets to your product, that just makes sense, right?
Yeah, I think the real advantage there is actually, in terms of, because your back end is always the thing that's going to get hammered, right? Like the front end, I mean, like 9 times out of 10, right? You're just delivering HTML to people, right? It doesn't require, like, people were doing that on, Pentium, but like, it was probably, like, Pentium 1s, in 1994. And it was slower, but it's not a difficult computing task. So if you can, pull that away from that, then it means you can probably actually just end up saving quite a lot of money, or running it in a much simpler solution. So I think that has probably been one of the big drivers there, right?
Yeah, absolutely. And I think the other one definitely on the back end side is the containerization, right? Typically we tend to work with Docker containers, and effectively being able to package your application into a unit that can be deployed on my machine locally, but also the cloud platform throughout all the environments, right? Development environments, testing environments, and eventually production environments. That provides, in my opinion, a huge benefit, not just on the production environment, but all throughout the life cycle of building applications, right?
Yeah, it's the killer app, right? Is that a developer can run the production application with all the dependencies it's really a dependency management tool, because you had that old situation, right, when a developer would have a local development environment. It would take quite a long time to set up. You might have a virtual machine for it, and then those development environments would get out of sync with the production environments very quickly, and you'd go to deploy to production and nothing would work. Like Docker has largely solved that problem, right?
Absolutely. Yeah, and I think on that transformation from especially with a team that hasn't used containers before, the transformation from I guess a more traditional hosting environment that you might have on a single virtual machine or a single physical machine, I found that it actually requires quite a fundamental shift in thinking, right? Especially introducing the concept of immutability that's inherent to containers into the mix. That's something that might take a while for people to actually realize. There's no environment where you can go in and change a running application like you might have used to, right? Or if you do that, then whenever the container is rebuilt or restarted, you will lose the changes that were made in it, right? So yeah, I think there's a fundamental shift in thinking, going from traditional into containers, and I've seen quite a few teams that haven't really got there, right? They've ended up kind of implementing containers at a level where they still treat containers as pets, right? They still treat containers as virtual machines where they can just open a shell in and do a change and let it run as it has been.
Yeah, but they're way more fragile, right? Like the containers were designed to fail, right? The immutable thing was by design and from the start. I think it also applies to VPS solutions, like virtual servers. If you want to be able to do auto scaling, right, you're not going to have the if you want to be able to auto scale on demand, like in response to traffic, and not scale out by like scheduling in some engineer to sit down, deploy a server. If you want to do that automatically, your server's going to have to come up, and it's going to have to be the same as it's going to have to deploy itself. So you're going to need to build a golden machine image. It's very similar. I think the big benefits, right, in containers, and one of the reasons they were adopted, right, is the speed of startup time. It's the fact that you don't have to package a kernel in there and start an operating system. They come up in half a second, which means you can respond to increases in traffic really fast.
Yeah, absolutely. And again, on the software development lifecycle itself, right? You don't need to transfer a virtual machine image that's 20 gigs, right? You can transfer a container that's hopefully a lot smaller.
Well, you say that. I've seen plenty of. Speaking of Oracle, I've seen some horrendous Docker containers in my day. Yeah, you can get it wrong.
Very good stuff. The last point here on what you need to actually get from A to B, get from your basic MVP infrastructure into a scalable infrastructure and architecture, is around infrastructure as code, right? Our preferred tool tends to be Terraform for building IAC. Now, I think there are two schools of thought around implementing IAC, right? Because if you look at it at the face of what we showed on the best practice diagram, you don't necessarily need IAC to build that, right? What do you think are the benefits of actually using infrastructure as code rather than just going to a cloud platform console and building it by hand?
I think it's a difficult one, actually, because I think there's a lot of arguments to say there's a right time to start looking at infrastructure as code, right? Like if you're just getting started and are experimenting, like it's often helpful to experiment by clicking around in web consoles and things like that. I think the big benefit comes when you're hitting a mature production application, and any change in infrastructure it has the potential
and environments, right?
Yeah, and it has the potential to break things, right? If you manage your infrastructure as code, then you get the benefits that the software development community have been working on. I mean, like, software developers basically use very complicated databases to make sure that distributed databases to make sure that any changes they're made are tracked, and you can step through all the changes that you've made, and you can go like, okay, we changed this one character here, and everything broke, so if we change the character back, then that should fix things. So yeah, that's a huge benefit, right? I think.
Yeah, indeed. And I think in my experience, you will feel the pain of not having infrastructure as code at the moment you need to build a second environment, right?
Yeah.
Typically you will have a number of environments in your software delivery pipeline. You will start with a local development environment, then go into an integration environment or a shared development environment on the cloud. Probably have something like a staging environment, which reflects production to be able to do production-like testing, and then finally the production environment that's actually live for your users, right? And one of the very fundamental sources of software release failure comes from having differences between these environments, right? And specifically having unknown differences between these environments, where you build all the environments by hand, and guess what? When you do things by hand, you make mistakes, right? That's just human nature, right? And typically this means that you have something slightly different in your staging environment compared to your production environment, for example, right? So you release your software version all the way to staging, and then when you release it to the production, something suddenly breaks because something's different in production, right? So actually having infrastructure as code and having a way to deploy environments that are identical, or at the very least having a way of deploying environments where as code what the differences are, will give you the benefit of reducing a lot of the unknowns throughout the pipeline, right?
Yeah, and it's visibility, right? If you've got if you're starting to scale up, maybe you've got an infrastructure engineering team, maybe you've got your developers working on infrastructure, maybe you've got 5 or 6 engineers working on this. If they're all just making changes through the front end, there are tools in the cloud that allow you to track this kind of thing, but you need to know how they work. Sometimes you have to go through API requests and go like, okay, who did this, when, why, what changed. Whereas, if you're running things through that, you get real visibility. At this point, I've said this to you in the past, like, I don't really know how we used to work without it.
Exactly. Good stuff. So let's look at the common pitfalls that we've seen organizations get into when doing a transformation like we've describing today. Definitely one of the big ones is around cost, right? And the failure to actually predict what the costs will be. A lot of the cloud platforms provide tools for you to be able to estimate what your costs will be when you run a set of services that like you typically do in a cloud native application architecture, but they're not necessarily tools that have been built to be very easy to use for users, because obviously it's not in their best interest, right? So more often than not, when we've seen organizations do cost modeling on their own, they end up forgetting something like data transfer costs, or they end up actually architecting the application in a way which costs them more than it needs to cost. Things like cross-region data transfers. It used to be a huge problem with some applications in AWS and so on. Right.
Yeah. I mean, data transfer is the big one for some of the. I mean, for AWS in particular, it's a known issue in the industry that that is where a lot of the cost is. So if you can, if you're planning for, if you're planning to scale, having some idea about what's going to happen to your data transfers and starting to look at what those costs would be, and this also applies heavily to those front-end platforms as a service offerings. They generally, so Vercel charge you and Netlify charge increasingly large amounts of money depending on your data transfer. The same with the CDNs as well. Bandwidth is something you should really be aware of.
Yeah, absolutely. A couple of the other usual pitfalls that we see are around service selection, right? And if you, especially if an organization is kind of trying to re-architect their product in the cloud without having the expertise of the cloud platform, they tend to do suboptimal choices in the services and actually introduce bottlenecks where they will bite you in the head later on, right? So I think there's definitely a worthwhile point around really doing the research and understanding what different types of resources in the cloud provider actually are scalable as you expect to, right? Another thing that's somewhat related is indeed the performance testing and understanding the bottlenecks of the application architecture, right? So you can build something with your best intentions, but unless you actually test for the scale, test for the performance, you will potentially come across bottlenecks that you just didn't realize are there, right? Good stuff. I think the final point we covered quite well around treating containers like pets, right? Where they should be cattle. So when you start up a container in whatever container orchestrator or whatever container infrastructure you run it, it is cattle, not something that you would care for as you used to, for example, a virtual machine back in the day, right?
I think if you've got any kind of compute resource that's running something that's supposed to be stateless, then it should be disposable. The cattle not pets analogy is really it's quite savage, but it's you don't want to be having to rebuild something that was that took forever when you need it on demand, right?
True. Very good. Excellent. So just to close off before some questions, the key takeaways of this as we discussed, there's a right time and place to think about scalability and actually looking at technical teams where they tend to be very technical. They tend to start solving problems that they just don't have, right? They start to build scalability for things that actually might never be an issue at the life cycle of a startup or a product, right? So definitely don't aim to solve problems that you don't have, right? The serverless and the platform as a service thing is another thing to raise here. Serverless and PaaS are great tools to get to the market quickly. You don't need to spend weeks or months setting up servers and installing server infrastructure to run an application. You just use a service that does all of that for you, right? So typically, a startup that wants to get their product out there as quickly as possible should go with the platform as a service approach. But again, these platforms are opinionated for a reason, right? And that opinion, that feature means that they have limitations to certain use cases, right? And you typically come across those limitations when you are further on in your life cycle, right? So starting with serverless, starting with platforms as a service tends to be the right approach, but it might not last forever, right? Finally, around data and databases, this tends to be a point of pain for many organizations, and being able to select a platform that scales, tends to be a good approach from day one, because migrating database engines, migrating databases tends to be painful on its own, right?
Yeah, that's definitely true.
Good stuff. Excellent. We've got a question around what's the first thing that you should look at when starting to refactor your MVP for scale. So what do you think, Joe? What's the first thing to do?
I think making sure that the sort of your application logic and your data is segregated, right? So we've spoken a bit about stateless applications, but it's important, right? You need your application logic to rely on a separate data store, like a database, or even like just text files in S3, things like that. But it needs to be somewhere else. So it doesn't matter, what, it doesn't matter, which instance, which compute instance you've got, you'll still be able to run. So you can't really scale without it.
True, indeed. Excellent, very good. Well, thank you very much for joining. Thank you very much, Joe. That's always a pleasure chatting with you. That's really insightful. We'll definitely get you in for some of the next episodes when we start talking about how to get applications into the cloud, slightly more mature applications into the cloud, and we've got some security things coming up as well, which I know are very close to your heart.
Yeah.
But excellent. Thank you very much, and have a great rest of the day.
Thank you.
What does every successful person have in common? It's something they've had since childhood. It's their curious mind. Curious minds experiment. Curious minds try and sometimes inevitably fail. Curious minds get back up and try again. Curious minds learn. Curious minds innovate. Curious minds change the world. From our generation to the next. Releaseworks. We empower curious minds.